Hi, this is Yilin Gu. I'm happy to present my Coding 3 final project, which is rime2flower. This is a project using cycleGAN to realize the image-to-image transformation. Since the rime ice has been a metaphor for an ice flower, based on my observations in real life, I perceive that some people around me try to close off their emotions, personalities, sharp edges, with ice. From my perspective, everyone can bloom a unique flower, and sometimes you don't have to suppress yourself in order to conform to your surroundings. Just let yourself bloom. I will test the outcome by loading new rime photos and see if it can bloom into a new flower shape. First, let me introduce the network architecture. The cycleGAN model has 2 generators and 2 discriminators. Here is some key information about the discriminator. And for the generator. The next step is to combine the model. The generator is trained via the combined model to minimize for different losses. The discriminator is trained as well. Here, by setting the label to 1, we are telling the discriminator the samples are real. By setting the label to 0, we are telling the discriminator the samples are fake. Then we can train the model. Load 50 images to each pool A and pool B as an input to the discriminator. For each iteration, generate X real A, Y real A, X real B, Y real B, X fake A, Y fake A, X fake B, and Y fake B. Update the images to the pool and train the model. The generated results and models are saved every 500 epochs to record the progress. It is worth noting that when loading the real samples, it is important to use time, which goes from -1 to 1 to scale the images. After finishing all the works above, we can load the dataset and train the model. Since I'm running the code on Google Colab, I connected the path to Google Drive to get the uploaded dataset, which contains the images. In my dataset, Test A contains 168 flower paintings, Test B contains 168 rime photos, Train A contains 1,632 flower paintings, and Train B contains 992 rime photos. Once the images are loaded, the model could be trained. The trained models are saved as G model A to B and G model B to A to avoid repeating the long training step each time running the code. Here are some test outputs. Finally, we come to the most exciting part, which is to load some new images and experiment them with the model. These are some new rime photos I found online. By loading the images into the model, scaling them from -1 to 1, some beautiful outputs are generated. The performance of the project is evaluated based on both the generated image and the reconstructed image. In terms of the A to B model, the performance of the model can be assessed by comparing the similarity of the generated images and the input flower paintings in terms of pattern color and style. In this project, the generated images generally meet the criterion and show some surprising outputs. Another evaluation criterion was the degree of reproduction by comparing the reconstructed images with the input rime photos. The closer the two are, the better the model performs. In this project again, the reconstructed images largely reproduce the colors of the original image and did not allow any stray colors to blend in, although the contrast was slightly higher than the original image. Overall, I think this project did a great job in terms of achieving the core idea and meeting the objectives. At the end of this video, I would like to state the sources I have referenced in this project. All the links and detailed information of the original publishers are in the README file. The image datasets I used for both the rime photos and flower paintings are from Kaggle. The instance normalization code and the cycleGAN model code is referenced from GitHub. I also gained a lot of help from some tutorial and papers. Thank you for watching. Hope you like my project.